An astronaut leaves his spaceship for some experiment and floats freely in space at rest relative to his spaceship. Right? His friend in the shapeship ignites a rocket installed on the spaceship for a very short duration. Which of the following observations can you make relative to a reference frame moving together with the astronaut outside the spaceship? Right. Very common sense is the see very common sense is we know the exhaust gas speed will be very high when compared to the speed of the rocket. Therefore, you can apply that also to this. Right. So therefore, this is wrong. This is a wrong. Magnitude of momenta, that is a law of as per the law of conservation of linear momentum. As per the law of conservation of linear momentum. So momenta exhaust gases, momenta of spaceship is the same. So according to K is equal to P square by 2m, lesser mass will have more kinetic energy. That's all. A very simple question. By the way, anyone having doubt on this? Pakka? Sure? Right. Remember, I have selected only few questions. Just please watch this question, everyone. Please watch this. Top of a large block A, you have, read the question. Read the question carefully. The issue here is top of a large block A of mass 4 kg consists of a frictionless slope of height 40 centimeters. With which smoothly merges into horizontal flat portion. The block rests on frictionless horizontal floor. This is a smooth floor. Then stops after sliding a distance of 1 meter on the horizontal portion of the top of the block A. Find the coefficient of friction between the block B and the horizontal portion on the block A. Right. My question at this point of time, initially there is no momentum, sigma px is 0. There is no momentum in the horizontal direction. Agreed? At the time you release it. There is no momentum in the horizontal direction. Even finally also, both should come to rest. Right. What was my initial energy? mgh. So this should be mu mgx. X is relative, of course. You set 1 meter on the horizontal portion of the top of the block. So mu is h by x. Yes or no? And h, what is the height? 40 centimeters. What is x? 1 meter. 40 by 100. 0.4. Mu is 0.4. I'm asking you, ECL students, do you have any doubt? You can comfortably question me. Stay nearby the mic. You can respond to me. One student tried to respond me. Have you all followed? One student say yes for this. Okay, thank you. Right. Very important model. You will definitely, you can expect to approve. I'm expecting today's back, if possible. If not, some other day cumulative examination. ఇది కొంచెం డిఫికల్ట్ అయినా తప్పదు. ఇది రిపీటెడ్ మోడల్. ఇది పవర్ బేస్డ్ యాక్చువల్లీ. Read the question carefully. Everyone read the question carefully. Everyone read the question carefully. You have a small block, mass M, placed on a plank of mass capital M, which rests on a frictionless horizontal floor. You have coefficient of friction between the block and the plank is mu. You have mu here, right? And this is smooth. Remember the moment when the lower block is, this portion is smooth, it's an easy question, right? Now you have given some impulse. Don't forget the system has initially some momentum along x direction. Yes or no? Since it has some momentum along x direction, I can confidently say that finally also there should be some common velocity to this system. Finally, when that particular system has common velocity, then you should admit that finally I could manage something, law of conservation of linear momentum. Somewhere you should admit. For this purpose, what I am doing is, see, at some instant, I know here initially the speed with which you projected it is u. I know. At some time t, let v1 be the velocity. And what is the opposition? Mu mg. Counter mu mg on capital M. This is a small m. Right. At some time t, they will have common velocity. Once they attain common velocity, friction disappears. And together the blocks will move. So, so I am writing it for the lower block. This is for the lower block. For the lower block, 1 minute. For the lower block, or mu mg by capital M is the force, acceleration. So V2 is AT and V1 is U minus mu ZT. So therefore, once you said V1 is equal to V2, you can equate this. After equating that, why you are equating this? This is the condition for common velocity. This is the condition for common velocity. So I have given you the T. No one asked a T. Okay, what is the work done by the friction? Simple. You see the problem in C frame of reference. In C frame of reference, the initial kinetic energy is small m capital M by small m plus capital M U square, right? Finally, the kinetic energy is 0. Why? Anyone in the class? Why? Once they move with common velocity, relative velocity is 0. What happens to all that energy? It is utilized in doing work against friction. So therefore, work done by the friction magnitude wise is this half small m capital M by small m plus capital M U square. Or here, simple. What do you want? Power. Power is work done by time taken. So I have substituted that the average power is mu mgu by 2. If you still have any doubt, ask me. Boys and girls, if you still have any doubt, please ask me. Are we clear? So what is the first idea in this question? Tell me. The first idea in this question is understanding why it attains common velocity. Thereafter, everything is normal, right? Now I am proceeding to question number 8. tick based questions only. I am expecting all these questions either today exam or in a cumulative exam. I'll post the notes immediately after the class. Anika, please take care that I post this. I'll post the entire file. అర్థం చేసుకోండి, మొత్తం ఈ చాప్టర్కి సంబంధించిన క్వశ్చన్స్ అన్ని చేసేసాను పాత్ ఫైండర్లో, మొత్తం ఇచ్చేస్తారు. అంటే ఇలా హింట్స్ గానే ఉంటాయి మరి రఫ్ వర్క్ లాగా. ఏ స్మాల్ బ్లాక్ rests on a flat bottom of a deep bowl that is placed on a horizontal floor. There is no friction between the block and the bowl. I want the statement. So all the places it's a smooth. Total mass of the bowl and the block is m. Hello. Mass of the ball plus mass of the bowl is a capital. Right. Now what happened? The ball is given a horizontal velocity by a sharp hit. The block rises to a maximum height h, sliding on the walls of the bowl. Which of the following statements are correct? Right. See, what I am assuming right now is what I am assuming, they are correct. So, what I am assuming is initially you can see here only the bowl will have u velocity because you have given impulse only to the bowl. Why not the block move? There is no friction. There is no friction. If there is a friction, we can think in a different way, but there is no friction. Only bowl moves. So that is the maximum kinetic energy that we can consider. That's what they are asking. Maximum kinetic energy of the bowl, right? Now, once as it moves gradually, what will happen? This will reach some height h. At that stage, both will commonly move together. Okay, stay here only. So now what is happening is applies in the C frame of reference, apply law of conservation of energy. Initial area I should have written actually in C frame of reference, I should have written half into m ball into m bowl by m ball plus m bowl u relative square. This is what I need to write. And this is equal to m ball time gh. Obviously, in C, this is what I have written here. So here you can strike m ball, m ball. So finally you can write half m bowl u square. This is what? Kinetic energy of the bowl. Maximum kinetic energy of the bowl. And this is equal to mgh. That's what they are asking, the first option. I have done S. Honestly, answer me, have you followed this or not? Everyone in the class. ECL students, have you followed this procedure, yes or no? Wherever it is necessary, I'm just writing this, rewriting the same step again. Are we clear? No response. Voice message, please. Voice response, please. కొంచెం దగ్గర కూర్చోండిరా మీరు, నాకు అసలు వాయిస్ రావట్లా. ఒకళ్ళు కన్నా దగ్గర బాయ్స్ లో ఒకళ్ళు దగ్గర కూర్చోండి. అరే నాన్న అక్కడ వాడు ఉన్నాడు కదా ఆ బ్లాక్ పక్కన బ్లాక్ షర్ట్ పక్కన ఆ, వాడి పక్కన వాడు ఆ, వీడు బాయ్స్ లో లెఫ్ట్ నుంచి సెకండ్ స్టూడెంట్ రైజ్ యువర్ హ్యాండ్స్. నువ్వు కాదురా నీ పక్కన వాడు. నువ్వు ముందరకు వచ్చి కూర్చో. సో ఇట్ ఈస్ యువర్ రెస్పాన్సిబిలిటీ టు సే ఎస్ ఆర్ నో. యు ఆర్ నౌ రిప్రజెంటింగ్ ది ఎంటైర్ క్లాస్. ఇప్పుడు ఈ ప్రొసీజర్ అర్థమైందా? ఎస్ ఆర్ నో. బట్ స్టిల్ ఐ కెనాట్ హియర్ యువర్ వాయిస్. ఐ డోంట్ నో వాట్ వెంట్ రాంగ్. అక్కడ 2 కెమెరాలు పెట్టారా ఏమిటి? మీరు ఒకసారి చూడండి. ఈ టేబుల్ మీద ఉన్న కెమెరా కనెక్ట్ అయి ఉంటే పీకేసి, ఆ టేబుల్ మీద ఉన్న వెబ్ క్యామ్ ఒకటి ఉంది కదా, ఈ కీబోర్డ్ పక్కన ఉన్నది, అది ఏమైనా కనెక్ట్ అయి ఉందా? అదైతే క్వాలిటీ ఉండదు. ఒకసారి వెబ్ క్యామ్ మైక్ దేనికి కనెక్ట్ అయిందో చూడండి ఒకసారి. హాఫ్ ఆఫ్ ద క్వశ్చన్ యాక్చువల్లీ. We still have a lot of the next part of the question. What is the next part of the question? If the bowl is lighter than the block, the minimum kinetic energy of the bowl is 0. Correct? Why? Because even you give impulse, see, if the bowl is lighter than, it is as same as heavy body. If the bowl is lighter than the block, the minimum kinetic energy of the bowl is minimum kinetic energy, maximum కాదు. There is a minimum kinetic energy. What is the minimum kinetic energy of the block? So what will happen in this case is, it is as same as a heavier body colliding lighter one case. Which means, see, actually what will happen thereafter, it will go like this. No, it will go like this. Thereafter, in the return journey, both will have some velocity. But if the block is heavier, what will happen is maximum kinetic energy will be retained with the block itself. Because this is lighter. Now what happens? The minimum kinetic energy of the ball becomes 0. Right. And last, to predict the minimum kinetic energy of the ball, we must know, yes, true. Why? Because now at this point of time, what I will tell you is m bowl times u is the initial momentum, m bowl v1 v2 plus m ball v1 is required. You require some ratio of these two masses. If you are not aware of the ratio of these two masses, you cannot find the answer for this. That's the problem. I repeat again, first part, everyone is comfortable. Even second part, everyone is comfortable. Now the problem with the third part. Already I have written the momentum conservation step here. Also, 1 minute, I will extend the page. Why should I compromise? So I know this. We will call this stage as A, we will call this stage as B, and we will call this stage as C. So I will now compare from A to C. Law of conservation of linear momentum. Agreed? Okay. That is the law of conservation of linear momentum. You can even apply law of conservation of energy also. M bowl U square is equal to half M bowl V2 square plus half M ball V1 square. So see, you require the ratio terms also in this. If you don't know the ratio, I cannot do anything on this. I cannot do anything on this. So you need ratios. It depends on ratios. Next. It's a very important question. Make sure that you understand this. Next. Next question. It's a theory question, by the way. A sledge on which you are riding is given an initial push to slide on a straight, level, frictionless track. Snow is falling vertically on the sledge. In the frame of the track, you have to adopt any one of the following three strategies to keep your sledge moving fast. Fastest, actually. Right. Till this point, there's a question. Now you have three steps. First one, you sweep the snow off the sledge so that it leaves the sledge perpendicular to the track as seen by you in the frame of the sledge. Remember, this is as seen by you in the frame of the sledge. Right. You sweep the snow off the sledge so that it leaves the sledge perpendicular to the track, as seen by someone in the frame of the track. What is the difference between the first and the second? Perpendicular to the track as seen by you in the frame of the sledge. As seen by someone in the frame of the track and the ground and ardham. This is with respect to ground. Third, you do think. Right. Now, what is happening in the case 2, we will see here. You can see the wedge here. It's a moving wedge in a sledge otherwise, moving in this direction. See, you are projected, you sweep the snow of the sledge so that it leaves the sledge perpendicular to the track, as seen by you. This is, actually for first case, this is the condition. In this case, what will happen? In this case, this will experience a thrust in this direction because you are throwing something out. This will change the direction of motion actually. But this won't cause any effect on the speed because the thrust, whatever you are having, is perpendicular to velocity. This is the first case. What do you want? To keep your sledge moving fastest. Next case, this is what you are projecting snow with respect to sledge in this direction. Why? You want with respect to ground. With respect to ground, it should be perpendicular. So what is the expression? Velocity of snow with respect to sledge is nothing but velocity of the snow with respect to ground plus minus velocity of the sledge. So velocity of the snow is a vector sum of these two things. So you need to push in this direction, throw in this direction, so that a ground observer sees that it is like this. Now you are firing it in this direction with respect to you. Because that you are firing it in that direction, you will experience a thrust force in this direction. The thrust will have two components. A component along the sledge, a component perpendicular to the sledge. A component along the sledge will increase the speed. A component perpendicular to the sledge will change the direction. So therefore, in second option, I can see increasing as well as changing in direction. So out of 2 and 1, 2 is preferred. Out of 2 and 1, 2 is preferred. In fact, uh, you have two options here. Anyway, first option should come 2. So therefore, C is wrong, B is wrong. C is wrong, B is wrong. So what should be the criteria? No, the other ways. The other ways. They are not doing anything, for example. If I am not doing anything, what happens? That also I'll discuss. Now, this is the sledge. This is the sledge. Say it is moving with velocity at a given instant. So snow is falling like this, right? So what is happening here? The falling, the fallen part, is it moving with what is the rating? Initial push to slide on a straight level frictionless track. Snow is falling vertically on the sledge in the frame of the track. In the frame of the track and with respect to ground. One of the following 3 strategies to keep your sledge moving fastest. You do nothing.
Is there something else I can help with?
We consider M as mass of sledge. Okay. And we need to define like sand falling onto the sledge. నిన్న మనం చెప్పుకున్నాం కదా. Let d small m by dt is equal to r. What is this called? So rate of fall of snow. I am assuming this is uniform. Now, what is the change in momentum? Additionally, what is falling? Tm into V. Force on the sledge is equal to minus of dm by dt times V relative. That is the sledge force. I am best to worst चाहिए आपको. Right. This is force on the sledge, which is opposite. So what is the acceleration of the, I'm speaking about the third case. Acceleration of the sledge is, this is nothing but R times V. The mass of the wedge, mass of the sledge. Of course, here, this is not totally m plus something, but negative acceleration. Let us take the, what is the third case? What is the first case? What is the problem with the first case? Let us, this is the third case. Let us take the first case. You sweep the snow off the sledge so that it leaves the sledge perpendicular to the track, as seen by you in the frame of the sledge. And now this is the top view. And the sledge is moving in the forward direction. నీకు perpendicular గా ఉండాలి. You are throwing that అప్పుడు మీరు ఎలా రాస్తారు? వెలాసిటీ ఆఫ్ ద స్నో విత్ రెస్పెక్ట్ టు స్లెడ్జ్ ఈజ్ వెలాసిటీ ఆఫ్ స్నో మైనస్ వెలాసిటీ ఆఫ్ ద స్లెడ్జ్. ఇది పర్పెండిక్యులర్ వెలాసిటీ ఆఫ్ ద స్నో with respect to sledge. So actually, this is how you are throwing the things out. So what happens here? Only difference there and here is a sledge is equal to same thing. Only problem here is m plus rt. This is m. ఏ కేసులో యాక్సలరేషన్ ఎక్కువ ఉంది, నెగటివ్ యాక్సలరేషన్ 1 and 3 లో. 1 and 3లలో ఏ కేసులో యాక్సలరేషన్ ఎక్కువ ఉంది? Very right. Denominator is high in this case. Fraction is less. So less retardation. More retard. This is a less retardation. This is a more retardation. So therefore, in which case slowing down is high. 1, it is high. See, according to me, 3 and 1 are similar situations. Only difference is in the 3 option, denominator is high. Yeah, yes, any doubt? నన్ను ఒక్కసారి వాట్ ఈస్ నేను చెప్పునా స్క్రీన్ షేరింగ్ స్టాప్. రైట్. In both the cases, you can see the denominator part is high in 3. Even though it is a slowing down, but when compared to 1, 3 cases relatively less. So therefore, best option is 2, followed by 3, and last option is 1. Any doubts? It's a good theory question. You are definitely going to get this question someday, either today or someday later. Any doubts? Ask me. Next, a very simple question. Particle of mass m moving with velocity u makes a head-on elastic collision with a stationary particle of mass 2m. Kinetic energy lost by the lighter, see, very fortunate head-on elastic collision. Kinetic energy lost by the lighter particle during the period of deformation means, so what is that the count you need to take from lighter particle, from its velocity v to common velocity. What is common velocity? V by 3. అరే ఇక్కడ ఉంది కదా, ఇనిషియల్ momentum by total mass. See, in collision, there are 2 processes involved. I told you. One is a deformation, the other is a reformation. Till deformation only they asked. So therefore, from V to V by 3. So initial K, and this is the final K. You asked me loss. So this is the loss. So you'll get 8 by 9 half mb square, 4 by 9 mb square. Any doubts? Simple question. Clear? Right. అరే నేను చెప్తున్నా ఈ క్వశ్చన్ ఉంది వాళ్ళు, అందుకే 2 స్టార్లు వేసా. ఐఎమ్ అజ్యూమింగ్ హియర్, సపోజ్ ఇఫ్ యూ డోంట్ గెట్ దిస్ క్వశ్చన్, ఐ హ్యావ్ నో ప్రాబ్లం. Suppose if you get this question, you are the fortunate one, right? Block of mass m is given a velocity towards another block of mass capital M kept at rest on a frictionless horizontal floor some distance apart from a wall as shown in the figure. Okay. If all the collisions are elastic, under which of the following condition will the block collide only once? Simple. After colliding, M should reverse back. M should reverse back. Okay, that is one option. What I am taking is, okay, in second body rest case, what is expression for V1? V1 is small m minus capital M by small m plus capital M U1. V2 is 2m1 by m1 plus m2 U1. Remember, in this case, obviously this is heavier than this. So if it reverse back and magnitude of if it is less than or equal to this, it never collide. లేకపోతే మీరు అడిగే క్వశ్చన్ ఏంటో నేను చెప్తాను, సార్ మీరు మోసం చేస్తున్నారు. See, first of all, you know V1 is less than V2. Never collision takes place. Suppose if V1 reverses, even then, to avoid collision, this is the condition. అంటే రివర్స్ అయ్యి ఇలా వెళ్ళి మళ్ళీ ఇలా చేస్తేయచ్చుగా, వాల్ని స్ట్రైక్ చేసి. వాంట్ టు అవాయిడ్ దిస్ ఆల్సో. అలా జరగాలి అంటే m minus small m less than or equal to 2m. m less than or equal to 3m. That's the condition. So any doubts, ECL students? Nana, any doubts?
Can you explain again?
Right, good. You know the formula for the expression of final velocities in a collision. Like this is m1, you assume. This is m2, you assume. It is moving with velocity u1, you assume, and it is at rest. In this case, these are the expression for velocities. Suppose if v1 is less than, undoubtedly v1 is less than v2 to add collision. But there is a possibility, sometimes what will happen is, so for example, if small m, there are two possibilities. Why should I confine to? If small m is greater than capital M, for example. In this case, small m minus m less than 2 small m. In this case, m must be greater than what? Tell me. M must be greater than minus m. Wrong case. Such a case is not possible. So therefore, not possible. So therefore, I have another option that the magnitude of this must be less than or equal to the magnitude of this. Then never collision happens again. For this purpose, it is not possible that we have concluded already. So capital M minus small m less than or equal to 2 small m. M less than or equal to 3 small m. That's the condition. Okay? Right. Next question. Remember, this is completely this week's syllabus. You are forced to, I have already discussed this question in my class content also. But still, you please go through the question. Two bodies A and B of masses 5 kg and 10 kg moving in free space in opposite directions with velocities 4 meter per second and 0.5 meter per second, which means the situation is like this. 5 kg moving with 4 meter per second. And the other is 10 kg moving with half meter per second in free space. The force F of their mutual reaction varies with time according to the given graph. What will you conclude from the given graph? Do you remember I taught you one definition? The entire area gives what? Deformation impulse. And the right side area gives the reformation impulse. The area of this part, by the area of this part gives you coefficient of restitution. Coefficient of restitution. Right. So therefore, A2 by A1. See, I know you have given time actually. You may ask me one thing. What is that? Let this be T. You may ask me, how do you know you got the T? That's the first question. You may ask me, how do you know that this is a T? How to find that particular interval? That I will teach you now. Now, what is the common velocity now? What is the common velocity in this case? The common velocity in this case is 5 into 4 minus 10 into half by 15. 20 minus 5, 1 meter per second. So what is the area? Area, you told me that it is a area impulse of deformation. So A1 is change in momentum of the first body. Final momentum, I know this is a negative value. Only thing, take modulus only. 5 into 4 initial, 5 into 1 final. 20 minus 5, 15. Modulus is 15. But this is nothing but half into base into height. So this goes 10 times. So what is a T? 2 by 10, which is nothing but 0.2 seconds. So I can find the time here, 0.2 seconds. So therefore, first option is correct. The moment I get the first option, I know this area and I know this area also. This area by this area is coefficient of restitution, 0.5. So this option is correct. Next. General formula thereafter. Body B will move with velocity 1.75 meter per second in reverse direction. What do you want? V2 formula is what you want. What is the formula for V2? Can you please help me? M1 minus M2 by M1 plus M2 U1. No, that is not V2. Second body is what you want. 2M1 by M1 plus M2 times U1 plus M2 minus M1 by M2 plus M1 times U2. Just substitute this data. M1 U1. M2 U2 place you substitute minus 1 by 2. By substituting, you will get 1.75 meters per second. Actually, you will get minus 1.75 meter per second. Total syllabus. GTM కదా సార్ మనకి ఎగ్జామ్స్ అన్ని సండేనే ఉంటాయి 2 సండేస్ మండే ఎగ్జామ్ పెడితే అది డేటా తీసుకో యాబ్సెంట్ అని వస్తుంది సండేనే 2 ఉంటాయి ఎగ్జామ్ నిన్న శ్రీనివాస్ రెడ్డి గురించి చెప్తారు ఎలా మేనేజ్ చేస్తారు చేయండి 2 ఎగ్జామ్స్ అయితే ఉంటాయి రైట్ ఓకే right. That's all. I am telling you this question you are going to face today. Because purely this week syllabus. అరే నేను చెప్తున్నా ఇది లేకుండా ఇప్పటిదాకా వ్యాట్ పేపర్ లేదు ఎక్కువ మీరు ప్రాక్టీస్లో కూడా ఇవి తగిలి ఉంటాయి మీకు ఇన్ ప్రాక్టీస్ ఆల్సో యూ గాట్ దిస్ క్వశ్చన్ రైట్ Particle projected at an angle theta with the horizontal from the center of the floor of a cylindrical roof, whose radius is r, returns to the point of projection after three elastic collisions with the walls and the ceiling. If the particle remains in air for time t, find the speed of projection. Remember, the total horizontal distance traveled in this case is 4r. Throughout the speed is u cos theta because all the collisions are elastic. Are no wali kutna you are what is the component of velocity u cos theta horizontally all the thing in a projectile. Even you collide wall also speed is the same. So therefore speed you know u cos theta. Horizontal distance is 4r. So therefore the time is 4r by u cos theta. So therefore u becomes 4r by t cos theta. Option B is correct. Whether you could do other options or not, at least B you can do. Now I'm taking a break here. ECS students respond. Have you understood option D?
Sir.
ECL students, have you understood option D?
Sir.
Okay, right. Thank you. Next. See, if the particle, find the speed of the projection. See, obviously, if possible, range is 4R. If possible, range is 4R. Yes or no? By all means, if possible, range is 4R, according to me. Everything goes fine. But here you can see the total distance is 2R. Obviously, 2R is less than range. We know, common sense. So 2R is less than u square sine 2 theta by g. U is greater than root 2RG by sine 2 theta. Yes or no? Now, you may ask me, how do you got this idea? Look at the options. Just to look at the options. Who knows that is the range? Did I mention to you that range is 4R? No. I did not mention range is 4R. Did they mention that T is the time of flight? No. No. Hello, boys and girls. No. ఒరే నా వంక సీరియస్ గా చూడాల్సిన అవసరం ఏమీ లేదు. ఇప్పుడు చూడండి, ఒకవేళ ఇక్కడ వర్టికల్ కాంపోనెంట్ 0 అయితే, suppose if the vertical component is 0 here, for example, right? If the vertical component is 0 here, for example, then capital T refers to time of flight. Please tell me, is the vertical component 0 at this point? No. If the vertical component is 0 at this point of time, it won't travel in this direction. So I have no idea whether vertical component is 0 at this point or not. If the vertical component is 0 at this point, yes, there is a possibility. But you did not mention if T is not equal to time of flight of projectile. So if T is not time of projectile, then 4R is not the range. 4R is not equal to range of projectile. Obviously, when 4R is not the range of projectile, how can you say that the speed of projection is, అంటే ఇప్పుడు మీరు ఎప్పుడు కరెక్ట్ అని రాసుకుంటారు అది? When you will express that 4R is the range of projectile, C will become correct. So therefore, C is wrong, A is wrong. నేను చాలా బాగా చెప్పాను ఇది. టైమ్ ఆఫ్ ఫ్లైట్ టీ అని తీసుకుంటేనే పోద్ది క్వశ్చన్ మొత్తం. మీకు చెప్పాడు టైమ్ ఆఫ్ ఫ్లైట్ టీ అని? నో. అంటే నేను ఇంకా కొంచెం బాగా చెప్తాను, ఇంకొంచెం డయాగ్రామ్ ఎక్స్టెండ్ చేసుకొని. ఫర్ ఎగ్జాంపుల్, యాక్చువల్ కంప్లీట్ ప్రొజెక్టైల్ ఇది. ఓకే, నెక్స్ట్ ఇందులో ఫస్ట్ కొల్యూషన్ ఇక్కడ జరిగింది అనుకుందాం, నెక్స్ట్ కొల్యూషన్ ఇక్కడ జరిగింది అనుకుందాం. నేను బాగా చెప్పాను. ఇప్పుడు మీకు మిర్రర్ ఇమేజ్ ఎక్కడ స్టార్ట్ అవుతుంది, నెక్స్ట్ జర్నీ ఇక్కడ స్టార్ట్ అవుతుంది. దానికి కరస్పాండింగ్ నెక్స్ట్ కొల్యూషన్ ఎక్కడ జరుగుతుంది, ఇక్కడ జరుగుతుంది. అంతేగా? మీకు ఇప్పుడు అందంగా చెప్తాను నేను. ఇప్పుడు హాఫ్ సిలిండర్ ఇక్కడ ఊహించుకోండి, హాఫ్ సిలిండర్ ఇక్కడ ఊహించుకోండి. అంటే ఇప్పుడు ఈ పార్ట్ ఇప్పుడు 0 A B C D 0. ఓకే, అంతా ఫాలో అయినట్టేనా? ఇక్కడ చూపిస్తున్నా. ఓ ఏ ఏ బి, ఇది బి, ఇది బి, ఇంకోటి సి కూడా, డి. ఓ నౌ టెల్ మీ, ఈజ్ దిస్ కంప్లీట్ ప్రొజెక్టెడ్? 0 to A to B, B to C. బి అయిపోగానే వెంటనే సి సిచ్యువేషన్, బి ఆర్ సి ద సేమ్. సో ఇప్పుడు మీకు ఇదే సిలిండర్లో చూపించినప్పుడు ఏం జరుగుతుంది మీకు? నేను అడిగినప్పుడు ఏ షేప్ కావాలో అది గీటల్లా. యాక్చువల్లీ దీన్ని జిన్నా చేద్దాం. Again and again. Is the sharing happening?
Sir.
Right. అరే యార్ ఇది సిచ్యువేషన్ ఇక్కడ. ఈ రివర్స్ అయిన తర్వాత ఈ పోర్షన్ ఇక్కడికి వస్తుంది.
Sir, sir, the screen
Yes.
is not sharing.
Yeah, tell me.
The screen is not sharing, sir.
It might take some time. Actually, hold on. Because signal is lost. I'll stop share and again I'll start sharing you again. Now tell me, what is the quality of the screen right now? Is it clear? Boys, is it clear?
Yes, sir.
Right. Now this is again going back. This portion A, this portion is B. Right. And again immediately B acts like C. And again this B or C. Immediately this point acts as a D. This is how it come back to. So therefore, don't estimate that this is going to be 2 hours. Okay. Next 24th. Lot of teachers fail in teaching this properly. Distance. Traveling a distance on a bicycle is less toiling than running the same distance in equal time. Which of the following factor is responsible for its well-known fact? While you do bicycle part, while you do bicycle part, what will happen is the center, you sit on a seat. Your, what do you call it? You will do pedaling. But the center of mass of the system throughout is at the same level. But while you are running, imagine you will do jumps actually. అంతే కదా, one leg, next leg, one leg is in air, you take the support of the next leg, next leg, next leg. So actually your center of mass unknowingly follows a path like this. Maybe lesser height, but unknowingly it follows something like this. Okay, so what are the factors? Mechanical advantage of the bicycle is not the criteria. Friction has nothing to do, and even if it exists, it won't do any work because your toe with respect to floor is not slipping. So what is the criteria is gravity. Thus, while walking, what is happening? Walking or running? Running, our center of mass keeps bobbing up and down. That's the reason. Every time, even if it shifts 1 millimeter or 1 centimeter, yeah, against gravity, you must do that much work, which you can't, you don't require in bicycling. Next. ఇది మీరు చేయలేరు. 16th question చూడండి ఒకసారి. A shell fired from the ground exploded into 2 fragments. అరే ఇది థియరీ బేస్డ్ క్వశ్చనే, మీరు మేనేజ్ చేయగలుగుతారు. ఇంకా కొన్ని క్వశ్చన్స్ కంపల్సరీగా డిస్కస్ చేయాలనుకుని నేను ఇంకా చేయలే, టిక్ పెట్టే కానీ చేయలే, మరి స్లో అవుతుంది నాకు. ఈ క్వశ్చన్ చూడండి, ఇది కంపల్సరీగా వచ్చే క్వశ్చన్స్ లో ఒక క్వశ్చన్. 2 identical small balls A and B, each of mass M, connected by a light inextensible cord of length L, are placed on a frictionless horizontal floor. With what velocity U must the ball be projected vertically upwards so that the ball A leaves the floor? The acceleration of the free fall is G. It's a very, 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 very standard question. Someday you will face this. But try to please understand. You projected it. You remember sigma px is equal to 0 in this case. There is no horizontal momentum in this case. So which means, suppose if you feel A experiencing some velocity V in this direction, to compensate linear momentum, B must also have a velocity V in that direction. Now you be in the ball frame of A. Then with respect to the ball frame, B is having a velocity of 2V. Agreed? Agreed or not? Now, what is the initial kinetic energy? Half mu square. Apply law, according to law of conservation of energy. Total energy initially is only kinetic. Total energy finally is 2 times half mv square plus the center of mass lifted by how much? No, m. This mass is lifted by L, mgl. Using this, you have this equation: u square by 2 minus gl is equal to v square. అలా చెప్తారు. Now, this is, you assume that this is in a circular path. So what is the centrifugal force on this? M times 4V square by L. For the tension to remain taut, this should be balanced with the how much force? Here, this should be balanced with how much force? See, remember, already there is a tension force, weight force, normal reaction force. When normal reaction becomes a zero, tension becomes mg. So with respect to this observer, tension plus weight is 2 mg. So on this ball, the downward force is 2 mg. Centrifugal force is m times 4v square by L. M cancel. So therefore, you got v square term. What is v square term? V square is nothing but 2Lg. And I have substituted in this equation, u square by 2 minus GL is 2GL. U square is 2 times 3GL, which is 6. Here is my calculation correct? No. 2 on the right. So it is GL by 2. So this is 3GL by 2. This will be 3GL. So therefore, U is root 3GL. If you project with root 3GL, it will just lose contact. If you project with more than that, it will definitely lose contact. Any doubts? I'm telling you, you are definitely going to get this question. Any doubt? Ask me now. ECL students, any doubt? I think your class time is out. You can go to your class. Anything else, record in this and post you back. Okay? So if your class time is out, you can leave. No issues. Right. You are definitely going to get this question. One more important question. All I have done, but the issue is time. This one. In a gravity-free space, small ball is placed at the center of a box, the same mass. The ball and the blocks are moving with velocity v towards the ball. Assume all collisions to be perfectly elastic. How many collisions are possible? Find the velocity area final ga enti. Issue is, yesterday we have done one question. Do you remember? Same situation. First box will collide and bounce back with the after box collide box colliding wall. Immediately after the collision, the box will have a velocity v in this direction, but still the ball is moving with velocity v because it did not felt any collision. Then what happens? After some time, somewhere in between, now suppose if this distance is L by 2, at a distance of some L by 4, they will collide. The point mass will collide the box. What happens? Velocities gets exchanged. Then what happens? This is collision 1. Collision 2. What happens? Again, the box will get a velocity v in this direction. Ball will get a velocity in this direction. Thereafter, what? This is ball colliding left wall of box. Next, what happens? The box, after colliding with the wall again, it moves rightwards. And the ball is also moving rightwards. So they will never collide. So again, what is this? Box colliding wall. So totally how many collisions? 3 collisions. Finally, what is happening? Box as well as the ball moving with velocity v rightwards. Any doubts? You are definitely going to get this question. Next. ఇదొక్కటి తప్పదు ఇంకా. ఇది ఒక్కటి చెప్పి ఆపేస్తా. 4 identical small blocks marked 1, 2, and 3 and 4. 1, 2, 3, and 4. You can see that. But they have different separations. A, B, C. Right. And they are colliding the left side wall. All collisions are perfectly elastic. What happens? Simple. 4 becomes 1. 3 becomes 2. అంతేగా? సోల్ చేంజింగ్ అని చెప్పాను మాట. After all the collision, the first block retains the last block property. Okay. Which means between first and second block, the gap should become last and last but one block. That is the reason why it becomes C. Next B. Next A. Any doubts? That's all. So I'll just stop because ఇది కూడా ఒక్కసారి చూసేయండి. Is it possible that after an elastic oblique collision between the two identical balls, one of them will stop? It is possible if the collision happens like this. పైది చూడండి, it's moving rightwards. కింద చూడండి, it is moving upwards along Y. సో ఇది లైన్ ఆఫ్ కొల్యూషన్ అవుతుంది. ఇప్పుడు లైన్ ఆఫ్ ఇంపాక్ట్ అవుతుంది. అప్పుడు ఆటోమేటిక్గా ఏమవుతుంది? దిస్ విల్ కమ్ టు రెస్ట్. దిస్ విల్ కీప్ మూవింగ్ విత్ వెలాసిటీ. It is coming to rest. For this to happen, the velocities must not be parallel. They must have components. Particularly this particular case, it is possible. Right. That's all. Good class. Next class.